Hi, welcome to the Dynamics tutorials. So with this problem we're going to be looking at a kinetics problem using the equations of motion, force, and acceleration. And we're going to be looking at a problem that will be undergoing translation only. So in this case we've got a rail car. It has a mass of 100 kilograms. It has a center of gravity that's located here. It's just resting on the ground here. I forgot to show the ground. And then we have 500 newtons that's being applied to it at an angle of 30 degrees. So over here would be our free body diagram. This would be the normal force on the one wheel, the normal force on the other wheel, the weight acting at the center of gravity, that would be the 100 grams times the 9.81, so 981 newtons. And then there's our 500 newtons at an angle of 30 degrees. So we'll do our sum of forces in the x direction, and the only force is the x component of the 500 newtons. So it'll just be 500 newtons cosine of 30. That will equal the mass times the acceleration of the center of gravity in the x direction. So we can solve that for AGX, and we'll get 4.33 meters per second squared. Then for our sum of forces in the y direction, we'll get the y component from the 500 newtons, so 500 newtons sine of 30, the negative 981 newtons from the weight, plus the two normal forces, and then we could use that to create an equation for the normal force in terms of the other normal force. Then we'll do our sum of moments about the center of gravity. So since this one is translation only, that means our angular acceleration is 0. So this is going to be sum of moments is equal to IG alpha, and alpha is 0. So this is just going to be 0. So we have our NB times 2 meters, and that's a positive moment. We have our NA times the 2 meters, and that's going to be a negative moment about G. Remember, all these have to go back to G if we're using this equation. Then we have the x component from the 500 newtons, so it's going to give us a negative moment about G. That's times the 1 meter in the y direction. And then we'll have the 500 newtons sine of 30, that'll be the y component here. That'll give you a positive moment about G. So 500 newtons times sine of 30 times the 3 meters that we have in the x direction. That'll be equal to 0. And then I ran out of room, but if you just substitute this in here and collect the terms, you'll get that NB is 286 newtons, and you'll get that NA is 445 newtons. And that would make sense that NA is a little bit larger because this force is sort of pulling up a little bit on that NB end, so that'll cause NA to be larger than NB. Thanks for watching.